So multiple variables require an aggregate distance measure. So for if you have more than so for each of the attributes, the distance will be computed, and then all the distance measures will get aggregated at the observation level, and based on which the distance will be computed, and the clusters will be formed. Okay. There are multiple measures of distance. One is very famous distance measure called Euclidean distance. This is how the Euclidean distance have been computed. So Dij is the distance between uh, observation I and observation j. Xkj value of the variable xk for observation j. Um, so this is how it is computed. And Dij is the city block or Manhattan distance, but widely used distance measure is the Euclidean distance measure. Okay. Other distance measures are Chebyshev's, Minkowski, Mahalanobis. Those distance measures are people do use. Mm. Correlation measures, these things are there, but generally widely used measures is Euclidean distance measure. And we will primarily focus on non-hierarchical, which I will show it through R. Um, Non-hierarchical do not follow a hierarchy, of course, in and then here actually it asks for the input from the user, that how many number of clusters are required. Then it splits the data based on the attribute. So we have to pass on two things. One is the number of clusters that is required, and on the other side we have to pass the number of the set of variables on which, or the attributes on which I want to form the cluster. Okay, so based on these two, the clusters will be formed. Optimal clusters will be formed. So optimal, when I say, so optimal means you have to identify the number of clusters very judiciously, or very optimally. Okay, but I will show you on how one can use identify this optimal number of clusters using R. And this is basically the using R, how we can do. So these are the steps. One is the data preparation part, where the primary important thing is identify the set of variables on which you have to run the cluster. That is number one. Number two is you have to identify whether if there is any missing or not. So if you have missing, you can either remove all the missings, or you can impute the missings using mean or median, or you can use regression imputation if you have more than 5% of the missing and less than 10%. So if it is 5 to 10% of missing, I would recommend go ahead with the regression imputation. mm. And then as you can see that partitioning, so k-means is a most popular partitioning method. It requires the analyst to specify number of clusters to extract, but I will show you one plot which is called elbow curve. So this elbow curve will help you to identify how many number of clusters are optimal, and then you just have to feed the number of clusters, optimal number of clusters here. Okay, here, and then you have to pass the data, and then you will be able to get the clusters. Also you can do the initial summarization for each of the cluster, and finally you can add the cluster number to your original data set. So these are the things we will conduct using R. So these are the three packages which are very important. In my system it is already installed, so I am not running first three lines. Okay, whether you have installed or not, if these three steps has to be executed every time when you are performing your cluster analysis. So this is basically referring to these packages. Okay, then we have a data, we have a cross cell data. So before that, let me remove all the things which are present in my current directory. So rm list equals to ls will remove all your um, uh, temporary data sets which are present in your directory. Then I'm reading the data. So data underscore cluster, this is basically a financial data, and as you can see, through you can screen through the variables and identify whether which variables are what, and whether all variables are in a right format or not. For example, account ACCT age is basically account age. So as I said, this is a card related data. So card balance, card information, savings balance, ATM amount, ATM pos, direct deposits, DDI is basically checking balance. So these things are there. So you have to check whether all variables are in a right format or not. So account age is not in a right format, it is taken as a factor. You have to convert it into numeric. Then you have a DDA BAL, which is into numeric, direct deposit, NSF amount, savings balance, ATM amount. POS amount is not in continuous, it should be numeric. We have to convert it into numeric if required. And then CC BAL is a credit card balance, which has to be numeric. Then income has to be numeric, which is in factor. So those things has to be converted. For the time being, I will just take I have decided to take 1 2 3 4 5 variables. One is account age, DDA balance, savings balance, ATM amount, and credit score. So based on these 5 variables, I will be running cluster analysis. So what I have decided to first convert the data into the appropriate format, because these two variables are not in a right format. So I have converted, and as you can see that once it is converted into right format, the missing will be identified and replaced by NS. Okay, then I have to do the subsetting, and subsetting is conducted by this, where I have to do this subset, then data underscore cluster. So you have to pass. So subset is a function. You are passing the data set name, then you are passing the list of attributes which you want to keep it in your for your cluster analysis, and run this. So data cluster 1 is having only 5 variables and 32264 observations. Then you are removing all your missing values. Here I am just removing or omitting or deleting my missing values. So we have 29,530 records. Then I need to identify the optimal number of clusters. So this particular piece of code will help you to run how to identify optimal number of clusters. So you have to explain you the code. So you have to pass this n row, means number of rows in the data. I am actually computing within sum of squares variance, that means within cluster variance. And as you can see in the x-axis and y-axis, in x-axis you have number of cluster, and in y-axis you have within group sum of squares variance. Within group means within cluster variance. Initially the variance is high, and as you keep on splitting into clusters, you can see the cluster variance is keep on decreasing. But after certain point in time, the cluster variance is almost stabilized. So if one has to choose very optimal number of cluster, maybe one can choose 5 or 6 or 7. uh, I am choosing here as 5 as my optimal number of cluster, but it is definitely one can change this number. So I am plug in the number 5 here, plug in the dataset is data underscore cluster 1 after removing. Then please remember that everything will be stored in fit once you run the cluster. So you please run this. So this fit will come here, and large K means 9 elements 1.1 MB. So this will ensure that all the outputs are stored here. Then this ensures that I have run the cluster analysis, K means cluster analysis, and I want to see okay how the cluster overall each cluster looks like. So let's run this. This is initial summarization of the cluster. So group 1 2 3 4 5. So for first group, what are the attributes I have selected? Account age, DDA balance, savings balance, ATM amount, and credit score. Account age for the first group is 7.6, probably month. And then DDA balance or check-in balance is 3370, savings balance is 45,000, ATM amounts, this is basically the median of the first cluster. Okay, ATM amount is 3637 and credit score is 670. If somebody asks me that how cluster 1 is different from cluster 2, so cluster 1 is different from cluster 2 with respect to with very much difference different in respect to DDA balance or checking balance. With respect to savings balance, it is also different. With respect to ATM amount, it is different. Credit score not significantly higher, but not different, but yes, it is to some extent it is different. So over on net I can say that okay, these 5 clusters are good, that the entire portfolio can be split into 5 groups, and these are the overall median for each of the groups or the representative value for each group. Now I want to, it is very important to attach the cluster information into the data set. So what I am doing is I am just attaching the cluster into this data set. So one can see this is just a cbind function I have used, and for each of the observations I have attached the cluster information in the sense that the cluster number, and one can run very simple table and then dataset name dollar. So this will tell you that in each group how many number of observations are present. For example, in the first group, first cluster, 819 observations are there, second group 21, third group 47, fourth group 410, and in the fifth group 28233. This may happen so because I have just randomly chosen 5 continuous variables, but if one chooses the, I mean, after doing some amount of investigations, if one plug in these attributes, definitely they would get the better results. Then this will just from the plot perspective, so this plot will show you the how these individual clusters are separated with respect to the 2 principal components. That means from 5 variables, the 2 principal component or after reducing the dimensions, because if I want to plot it into 2-dimensional graph, I have to compute the principal component and how this how the chart will look like. This is number 1, and number 2, class plot. It's not coming. I don't know. So one can run class plot. Yeah. So this is basically the plot of the clusters 1, 2, 3, 4, and 5, and these are the observations. So what we have plotted we have plotted basically uh, in all observations, all the 29,000 observations, in by computing 2 principal component, by reducing the 5 attributes into 2 attributes, by computing 2 principal component, component 1 and component 2, and then plotting the observations on the basis of these 2 principal component. Okay, so that ends with the cluster analysis, k-means cluster analysis using R. Thank you very much.